This year in physics, we need to round our numbers properly. In order to do so, we have to understand this thing called significant digits. So they're all the numbers that are important to us, where they haven't been rounded at all. So basically, all digits included in a stated value are significant except for two case scenarios. One, if we have leading zeros. So if you have the number 0, 5, the 0 in front's not important, it's just a 5, so there's only one significant digit there. Or ending zeros if no decimal is present. So if you look at, say, a population sign where it says Strathroy's population is 15,000, well, there's not exactly 15,000. There could be 15,001. So we know that's a rounded number, so only the 1 and the 5 are accurate, and we only count that as two significant digits. Now, if there's a decimal place, so let's say it's 3.0, well, that decimal 0 means I've actually measured it to an accuracy of the tenths. So I know that's important, or else I would have just written the first number alone. So let's try some of these examples. So in the first example here, I have 007. This is an example of leading zeros, and they're not important, so there would only be one significant digit. In this one here, there's no zeros at all, so everything's significant. So I have 1, 2, 3 numbers, so I have 3 significant digits. In the next example, I have 3.00. Well, I've taken the time to get the accuracy to 2 decimal places here, so I know they're all important, because it would be easier for me just to write down 3. But if you see decimal and then zeros following it, I've taken the time to take it to that accuracy. So in this case here, there's actually 3 significant digits. Here are 3 ending zeros where there's no decimal place. So I would assume that this is a rounded number, and only the first 2 numbers are significant. So there's only 2 significant digits. Here's another example where I have leading zeros, and it doesn't matter if there's a decimal or not. Whenever you have leading zeros, they're never important. So there's only one significant digit here. So what we have to remember is if you have leading zeros, okay, they don't count. Ending zeros don't count as long as there's no decimal place. Scientific notation. We did this last year, so this is just a little bit of a review. In scientific notation, the number is expressed by writing the correct number of significant digits with one non-zero digit to the left of the decimal point. So basically, you find your first whole number that's not a 0, and you put the decimal place right there next to it. And then multiply the number by the appropriate power of 10. If it's a positive exponent, then we know it was a really big number. If it was a negative exponent, we know it was a really small number. So here's our first example where we want to put this into scientific notation. Well, you would put the decimal right after the 6. You find the first number, put a decimal down. So it'll be 6.807. And then you need to know, well, how many times did I move the decimal place? Well, if the decimal was here, we moved it 1, 2, 3. So you end up with 6.807 times 10 to the power of 3. Here's an example where we have a negative exponent. So if I move the decimal, so I have my first whole number that's not a 0, and I put the decimal place, so it'll be between the 3 and the 2, I moved it 1, 2, 3 times. This was a small number, okay? So what I need to do is indicate that with a negative 3. So I make the exponent negative. So it's 3.2 times 10 to the negative 3. When you have positive exponents to the 10, that meant we have big numbers, bigger than 1. If it was negative, it meant it's smaller than 1. Scientific notation is optional between numbers of 1 to 100. So if you have 150, you need to change it to scientific notation. So when we do calculations, we need to round properly. And I'm going to go over the rules now. So when we're adding and subtracting, this is the rule for adding and subtracting. It says when adding or subtracting measured quantities, the answer should be expressed to the same number of decimal places as the least precise quantity used in the calculation. So if you punch in your calculator 15.35 plus 236.4 plus 0.645, you'll get this answer here. You'll get 252.395. Now, according to this rule, least precise means the one with the fewest decimal places. So this one's got 2 decimal places, 1 decimal place, 3 decimal places. So the middle one here, it's got the fewest decimal places. That means it's been measured the least precisely. So my final answer needs to be rounded to 1 decimal place, So when I look here, I want this placement here to be my last number. I look beside it, it's a 9. That means the 3 needs to round up. If it's greater than the 5, we need to round it up. So your final answer you need to write down on your tests and your assignments is 252.4. And again, we rounded it up because when you look beside the 3, it was a number that was greater than 5. We don't always just add and subtract. Sometimes we multiply, divide, or find the square root of a measured quantity. If you're squaring something, that's like multiplying, so it lands under this category as well. So when multiplying, dividing, or finding the square root of a measured quantity, the answer should have the same number of significant digits as the fewest number of significant digits used in the calculation. So multiply these two numbers here. So 65.6 times 0.62 gives you 40.672. Well, in the first number, I have 3 significant digits, 1, 2, 3. In the second one, I only have 2 significant digits because leading zeros don't mean anything to me. So when I round this number, I must round it to 2 significant digits. So that means if I want 2 significant digits, it's going to be rounded to 41. The 0 becomes a 1 because that's bigger than a 5, so we round up. So my final answer is 41.